Good morning, ladies and gentlemen. I'm actually Xuetao from the Beijing Yunify Technology Company Limited, and I'm an engineer there. And as for my colleague, Fang, he's ill today, so I will have to deliver the speech by my own. And today I would like to talk about Porter. And it's actually an open source load balancer for bare metal Kubernetes. Introduction first. Why do we need to use Porter? When we use K8s, if we want to access the service there, we'll have to use service IP. But as for service IP, it's actually a virtual IP installed. And it can be reflected in the following aspects. First of all, for service IP, it's actually managed by QB proxy through IPPS or IPVS. And the service IP can only be accessed in cluster. And also, the service IP is not bound to any device. There's no service IP in any of the gateway, but still we need to access the service or IP. Therefore, K8s has enabled us to access the service. First of all, the first one is not port. It's actually the mostly commonly used to expose service to external and just to do a mapping to the terminals and through the host IP as well as the terminals, we do the access of the service, but it's really hard to remember because it combines host IP as well as the other address, and it's really hard to name that. And also, secondly, the single point as well as the bottleneck problem can be very random. It can only be operated in the test environment in this way. And when we're going to access not port, of course we have a host IP, but if the host is down, then the user cannot access the service anymore. And even if the K8s can still enable the normal service, but externally, when the host is down, there's no way for you to again access the service anymore. And secondly, it's about ingress. And it's also the frequently used method to access the service. First of all, I would say it will deploy the service by domain. It's in this way very understandable, but it still got its problems. For ingress to work properly, we do need to expose ingress to external. And there's no ingress, unfortunately, for the ingress controller. And secondly, it's actually for if we use no pod or host work to expose that to external. Again, it's using the host to access the service. Again, if the host is down, the ingress is down, but still the service is up and running still. It's actually maintained by developers and it can still be used in this way. And thirdly, for ingress, we can only use L7. Usually ingress use Nginx. There is modular support called Stream, which has 4 layers, but still it's in the test period, it's not that stable. Therefore, for HTTP can be used to expose the ingress to external, and as for other kinds of service, we seldom use ingress. And thirdly, it's called LoadBalancer. For LoadBalancer, it's often used by cloud technology provider. We use the IP to bound that to our service. All we need to do is just to deploy a K8s, then we can use LoadBalancer to expose the service to external. It's very convenient and user-friendly, and also you can attach a domain to the IP, and it can be thus very easy to remember. And again, we use the LoadBalancer of the cloud technology provider, therefore there will be no single point default. And as for the traffic, it will be distributed evenly to the node. caused by the cloud technology provider. Therefore, there's no single point failure. And as for the con of that, it can be only available in cloud provider only. For example, if there's, bare metal Kubernetes, there's no way for you to use load balancer. In a nutshell, load balancer is for testing, but in grass it's convenient. But again, we need to find another way to expose that to the external. As for load balancer, if it's a private cloud, then there's no way for you to use that, and that's actually the disadvantage of that. That is the reason why we need to use Porter. Judging from its name, we know it's just a Porter, and it means package engineering in its English translation. It's balancer on cloud being relocated to the bare metal Kubernetes. It has basically 3 functions, as you can see on the screen. Like traffic load balance, IP access management, and open source. And some fundamentals about that. We use ECMP. It's actually a part of the function of Linux. Judging from its name, it has the same destination and has different pathways, but all the paths are actually equal to each other. That is to say, when we're going to the same endpoint or destination, we might have different paths leading us to the same destination, and basically that's the logic behind. And you can be able to see that from the picture below. For example, there's router, and if we want to go to destination, there's 3 paths: 1.1.1.1, 1.1.1.2, 1.1.1.3, and all of this can lead to the same effect. Any of the failure of any node, it would not really interact or seriously affect the entire service. With ECMP in place, we do need to have to use BGP to broadcast the ECMP. It's called Border Gateway Protocol. And I would say it's actually a collective of different properties. For example, it will support multipath. For general routers, it will support that, and for multipath, it's actually the same with ECMP. It will allow us to use routers or interchangers to have multipath leading to the same destination. As for BGP, it will choose one of them and to achieve the load balance. And as for this picture, it demonstrates how BGP really works in the entire network. For example, our user is out of the cloud and it wants to access the 1.1.1.1, and you can see different layers of routers, for example, for border and leaf layer, and through BGP, how are we going to access the service? First of all, you can see the servers at the left-hand corner or at the bottom. That's actually the servers you can use, for example, 0.2 and 0.8 there. And as for leaf router, it will deliver the information to the next level, and again there are 2 routers and they will be able to get the information. To access 1.1.1.1, you will be able to go through leaf 1 and leaf 2, and again the spine will be delivering the information to the border. And if you want to access 1.1.1.1, and then you can just go through the spine 1 and spine 2. And in this way you can see the access to 1.1.1.1 can be cleared, and it's constructed in this way, and we'll be able to do the connectivity here. And you can see altogether there's 2 times 2 times 2 times 2, altogether 16 pathways here, and you will be able to see that even for the 2 or 3 servers in 1 or 2 layers, or even some of them are actually down, it will not really interact or seriously affect the entire network. That is to say, any failure of the server or router will not really affect or badly damage the access eventually. And now let's see how the two rationales can be used to do the constructive work. First of all, for porter, it has two components. The first one is stable set. It has BGP server inside. For stable set, it's actually the brain. It's basically dispatching routers as well as IP management. And secondly, we got agent as well. We have the daemon set method to do the deployment in the K8s cluster. For example, if there's a new service that needs to be exposed to the external, then we do need to maintain some of the rules locally. And as for these agents, they would be responsible for the making rules, and it's really lightweight. And as for the porter, we have the CRD plus controller, this kind of standardized K8s to be actualized, and we can use list watch and cage, this kind of native K8s method to do the job. And the shining point or the advantage of that is that the APIs can entrust the IP, and if the user want to access the porter, they only need to code some Go language and then just to access the server. And also the control can use the order line to control the porter. Again, for load balancer actualization, we got a front-end load balancer, and at the back end we have the not part of a host or not part of different hosts to achieve the load balance. But in a default mode, for not part, it has a large drawback, that is to hide source IP. That is to say, through not part to access part, the port wouldn't be able to know the source IP. Rather, it will be able to only see the not at IP. Therefore, for any external application that requires auditing, it's really inconvenient because they can only see the not IP of a lot of nodes. But for AK8S, it has such a mechanism to skip the NAT, but it also has a drawback. If you want to randomly access a node, and as for the node, it can be accessed by not part, but at the node, there's no not part, then there's a dead end, and it will be a timeout without any response, and it's not good. And in default mode, we'll just use not to randomly distribute the information to the port with the, and with the port we'll be able to open up this service and to do the setup and use the locale to ensure that locally you always have your port. And as for this function, it can be controlled by port, and this port will watch all the endpoints. And as for endpoints, if there's any swivel about that, then for example from 1 to 2, then the not one's router will be deleted, and then there will be a second router. In this way, the front-end load balancer will always have access with not part, and our service will be able to set up such a property, and in this way we might only have one less route, and at the same time you will be able to see the real IP. And as for the application that requires auditing, I feel like it's really good. And as for the last function, for IP management, for load balancer, we have external IP plus class IP's mapping, and there's no way for clients to access host IP, and we have the external IP to access the service, and that's control GAT for and service. They will be able to access this external IP, and as for external IP, it should have to be controlled and managed. And as for the entire LAN, it will be spreaded, and there's no way for us to put an IP in the LAN randomly. It will, in this way, lead to conflict of IP address or even chaos. It will be a huge disaster in this way for the LAN. Therefore, we have this kind of function here in place to use dynamic or static setup of IP. For example, if you want to have the access to the service, you can do this. It can do that in a static manner. Of course, you can do that in a dynamic manner as well. You can just have the pool in place to tell the IP that all the IPs in this pool can be available, and then you just do the maintenance work to the pool. And as long as the service use our porter, then they will be able to get one of the IP out of the pool. And secondly, for CN space and namespace.
So we can design a space to use all those IPs in the domain, which is similar to chemical. And thirdly, for IP source monitor, we can, via promises, we can expose the availability and number of the resources that can be used. And externally, it can check the IP pool, the availability, as well as the traffic used. And for the latter part is the one that we are going to develop, and it is now in our plan. Here we talk about the complete working process of porter first. From watch and service, we start from service, whether it is a balancer or other type. If you monitor the balancer, then we'll go through a circle pool, and in the circle pool, from the IP aspect, we first check whether it's static or dynamic. If not, we can acquire an IP from the pool to give to the service to update the service. Once we got the IP, we will, while BGB embedded BGB service to add one routing to ensure that the internal IP, the routing can go via all the node with a port. And then we will check point, which marking the whole services and the location of the point of the port and node, and expose BGB service, marking that the paths that go through all those nodes and to direct the traffic. And it will be in control to broadcast all the routings to the network. In this way, the network will know there is a pathway that is maintained by BGB. And also we will watch the EIP sources. It's the CRD in the port. The function is, if we have a CRD in it, our agent will do some work. It need to, for the external routing, it need to lead to the internal, because it's not connected with the whole cluster, the whole devices. Normally, it will be given to drop, and we need to, from IP table, this approach. For all the table, we need to open it, to tell it, although this package is not open, we still need this package. And via Kubernetes, we will handle it later. And the same thing goes with BGB configure. It's also a CRD. For the BGB configure, its function is to, for BGP, it's although it's a protocol, it's a correction of the protocol. There are many BGP end protocol, many features, and via BGP configure we can dynamically configure all this one, and we will watch this to CRD, and with CRD, if there are changes, we can dynamically update the server. If we want to add a router in it, or to tell the BGP server that we do not broadcast certain things, we can achieve this via this kind of framework. To achieve the zero downtime, the portal is always in operation. We do not need to stop it to maintain it. And next, we'll move on to how to use the border. It's quite easy. Download the YAML from GitHub and apply it directly because it's a dynamic configured. After it's in operation, you can add the BGP configuration. For BGP configure, there are some certain kinds of formats. And here I listed the example of Porter on the left and Cisco on the right. Here we listed the attributes of the local Porter and all the figures listed, and like IP and Porter. And here I forgot to mention that normally for routers or Canicos plug in Kubernetes cluster, but Canico also use BGP. It will also cover the 179 connector, and also for some routers it only supports the end-to-end 179 service, only this one. But for our Porter, it will via some major principles to guide and shift the Porter and achieve the goals to be very competitive and in operation with other routers. And here, because we didn't use the standard 179, we need to tell the Porter we didn't use the standardized one. We need to transfer into other formats. And we configured later to connect the exchange machine with routering functions to set the address of the net gate. And the last one is telling it we need to send multiple routes, valid routes. Normally, BGP service, it would only receive one route if it goes to one destination. But if you open this one, it can receive multiple routing paths to achieve the function. And on the right, I wrote down the Cisco configuration because the routers of different manufacturers are different, and more can be found on my GitHub, including other configuration from other manufacturers. After the configuration is completed, the Porter can be put into operation. And in order to put it into operation, we need to add an app to the pool under the kube control, and we can add this address, this IP address, add this IP with address to the IP pool to ensure that it's unique in this local network. And after all those preparation, we create a service. You can see the name and with annotation, because using annotation to tell system to use the Porter for loading balancing. To tell it the service needs this Porter to use, and the tab is to be suitable for load balancing. In this way, you apply the control, and a few seconds later, you will have an IP, because it takes very few seconds to achieve all those functions. And finally, I will move to our plan. First, just like we've mentioned, the IP control, lot of domestic enterprises, they have very strict requirements for the control. You need to go through the NAT gateway, and we would like to provide more flexible IP configure, and also we would like to use other protocols or methods as optional way for users in very complex networks, for example, like in Kubernetes. To do not support BGP, we need BGP to flexibly configure the policy, not just every time we need to send the routing to the 3 exchange machines and with the same copies. That is a waste of resources. And also, we use BGP in this kind of a plan. And the third one, because some domestic enterprises, they have a misunderstanding of BGP. They thought BGP is not that safe to use. I'm not quite sure why they are thinking about that. And also, we wish that we could support BGP policy to control route advertisements via protocols. And also, this is my address at GitHub. If you are interested, you can also click the link, and we welcome you to try to use and give us feedback. We welcome your input. Thank you. Do you have any questions? I would like to ask one thing. The backend agent. I take a brief look. Does it mean that the coordination algorithm, which kind of algorithm do you support for some specific scenarios? It didn't handle those complex business. It means that one service, if we use the porter, then we need the internal IP because it cannot be built in the internal cluster. You need some principles. We receive a package, and normally the destination is the certain IP. We just drop this to make this process easier. Provided there are many backend, it needs to select one, right? Then it will randomly be distributed to one backend. Do you mean from the routers to the backend, or sometimes we need to maintain one mission to one task to one backend? That should be configured at the router. You need to make the configuration on the router. Normally, the BGP have this kind of features. So provided that this task go to the same load balancer, and when choosing the backend, for this step, for the how to deal with the consistency of this process. So we go directly from router is our load balancer. We use the router as the load balancer. So everything should be configured in the router. And also because the audience is not using the microphone, the interpreter cannot hear clearly. Okay, I think I understand this question. And any other questions? Something similar to your work. One is BP and second is second layer network. So what's the relationship between the two? For Porter, it's After the discussion in our team, we have this project after the development. We searched online to see whether there are similar competitors, and we found out this project. The biggest difference is that first, their LB, they have all the servers, and all the BGP servers are built and which supports very few features with few functions. Although they have the server on all the nodes, it's very heavy. For Kubernetes native, we are based on CRD. They are not. They are based on configure map. You need to complete the configure map first. That is the biggest difference. If there are no questions, I would like to thank you again for coming to this session.